So welcome to Hubbard-Hall Seen Solved. I'm Tim Pennington, Editor-in-Chief at finishingandcoating.com. Today I'm with Hubbard-Hall's Robin Deal, who's the product leader for their AquaPure brand. Robin, thank you for joining us today. I got lots of questions for you.
As always, it's a pleasure speaking with you, Tim, and I am prepared to answer your questions.
I'm Tim Pennington, and you're listening to Seen Solved, brought to you by Hubbard-Hall. Better results, less chemistry. Well, actually, this is going to be a kiss and tell episode right now because I'm going to ask you some questions that I want you don't have to get very specific, but if you can get better specific for our listeners, that would be great. But I know you've got some non-disclosures you can't talk about, but I really want to talk about some of your case studies that you've done with certain metals that seem to be, we're going to call this one meddling metals, the metals that seem to give most finishers the biggest problems, and I'm going to call out a few. Tell me if there's more. Chrome, which is on everybody's target. Nickel, zinc, copper. What else is out there that always seems to be causing problems?
Those are the four big ones. Occasionally, we'll get a call for something like cadmium. The most exotic one that I ever received a call for was thallium.
And that's an element. I'm taking your word for that, correct?
It is one of the radioactive.
Well, when that comes up on Jeopardy, I am set. But anyway, let's start with chrome. So are you talking hexavalent?
I've seen people struggle with both, to be honest.
Okay.
The first year I worked for Hubbard-Hall, we got a call from a large manufacturer. They had the city come out and cut their discharge pipe because they had been discharging hexavalent chrome unknown to them.
So they just come out and cut it. They didn't tell them in advance?
Well, the city called them and said, we're going to come out and see what's going on. When the city came out, they were not happy at all, and they immediately made them shut down their wastewater system, and they literally cut a 1-foot section out of their effluent pipe and capped and locked it and had said, you can't discharge water until you prove to us you know how to remove hexavalent chrome.
So science 101, how does a local wastewater sanitation, how do they know what's in the water? It's coming from a building to the city sewer. How do they know that? How do they know what the metal content is?
So city-owned or POTWs, wastewater treatment plants, have a discharge permit just like the manufacturers do. And their discharge limits are set in stone just like a manufacturer's are. If they see their effluent has an increase in a certain metal, they can track it by following their sewage lines.
Ah, gotcha. Going back upstream and just determining who it was.
Right.
And then they bring the chainsaw and they cut your pipe off.
Right.
Right. Okay. Well, that's kind of rude, but
in some cases, maybe you're the only manufacturer in the neighborhood discharging to the city that has hexavalent chrome.
And pretty much if you're a finisher, they're going to be able to track you down. You're probably the first stop on their detective route of finding out where this is coming from, correct?
Correct.
Okay, so hexavalent chromium, which, it gets all the play. It's called the Aaron Brockovich chemical. People are talking about it more than any, I think. And although it's natural in the environment, right? I mean, it's there, but correct. You don't want to drink it. You don't want to inhale it. But so talk me through somebody that had a problem. What was the cause of the problem? And then what was the remedy? So
the first step is of treating hexavalent chrome is reducing it to a trivalent state. The customer who had their pipe cut was not doing that step.
Right. And we should say hexavalent is a carcinogen. Trivalent is not a carcinogen.
Correct. So they had an operator leave, and the new operator did not like the smell of the reducing agent and did not know what it was doing or why it was doing it. So he just quit using it.
Makes sense.
So, and then secondary to that, they were using the wrong type of coagulant for chrome removal. So they were always even prior to the stoppage of the reducing agent, they were always struggling with removing it anyway. So the reducing agent they used was sodium metabisulfite. And anybody that works with this product knows how it's a very pungent smell, and it will literally take your breath away. And when you smell it, it lingers in the back of your throat. It's a very, very stout smell. But you have to use it. So to reduce hexavalent chrome, you drop your pH to 2.5 or lower, and then you introduce a reducing agent. Sodium metabisulfite is a reducing agent. Ferrous sulfate is another reducing agent. So there's a couple of reducing agents you can use, but the most cost-effective is sodium metabisulfite. Right. And you introduce this to your hexavalent chrome stream when your pH is at 2.5, and you watch your millivolts or your ORP reading as you introduce the reducing agent for a positive 250 reading. And then there's a noticeable color change. Hexavalent chrome is very yellow and trivalent is blue. So that's how you know you've done it.
So it doesn't sound like it's a difficult thing to solve those, right? It's just a matter of recognizing you got the problem,
right,
and then taking the steps, right?
Right. So once you reduce it to trivalent state, you want to remove it. A lot of chemical manufacturers will say to use ferric chloride or some form of aluminum. For chromium removal, the optimal type of coagulant is a ferrous-based coagulant. So you might say, well, Robin, what's the difference between ferrous and ferric? They're both iron. Ferrous has a higher affinity for trivalent chrome than ferric, and you can dose at a lower dose and remove much more trivalent chrome from your waste stream.
So let me ask you this particular shop, how long did it take to get them back up and running? I mean, you know, if you can't dispose your wastewater, but how long of a process was that to get it fixed?
So I went out to see them on a Monday morning. By Monday afternoon, we placed the order for the reducing agent for a ferrous-based coagulant and for the proper anionic flocculant. And we delivered the product to them Tuesday afternoon, and Wednesday morning we were treating wastewater. But because they had such a negative name with their city, we had to hold what we treated, and the city had to come out and verify it was good to be discharged. And so we discharged 10,000 gallons at a time. Manufacturing processes were up and running fully within a week, and it took us 6 months to gain the city's trust.
I was going to say, even after that, I'm sure the city has a target on their back and was probably spot checking or whatever they were doing was to really look at that. So again, message with that is, if you don't want to be continually hampered by a city or whatever, don't do it in the first place. And first of all, you know, and get the proper training with that. So now let's move over to nickel, which, you know, some people also consider nickel. I know in Europe they consider it a carcinogen as well. But you know, how is it that nickel would get high in a wastewater system, treatment system? How would it get through?
Nickel is one of those elements that for hydroxide precipitation to work accurately, you have to go to a pH of 10.5. Okay. Unfortunately, most industries don't have a way to bring the pH back down to discharge limits, which is typically 9 or below. So they raise the pH up to 10.5, which removes the nickel, but they can't lower the pH for discharge. So they typically don't go up as high as they need to, so that they would stay within their discharge limits for pH. So what that causes is you get less removal of your nickel. most chemical manufacturers will use an iron-based coagulant. They'll try to sell that to you. And for nickel removal, you really, really need a aluminum-based product to get the best nickel removal.
Do you do a lot of those? You see a lot of those? Nickel issues and things like that. Usually I know it's not just one metal, right? We know that, right?
Right. So we had one customer call us. They were using ferric chloride and lime. And they were producing a 20-yard roll-off of hazardous waste sludge every 2 weeks. And they were routinely replacing pipe and pumps from the lime scale buildup.
So this had to be taken to a landfill, correct?
It could not go straight to a landfill because it was hazardous waste.
Well, right. It had to be hauled off by somebody, right? Which is very expensive.
There's 23 hazardous waste facilities in the United States.
Right.
There's not that many. So it had to go to one of those.
Right. Which is expensive. That's what our point is that it's expensive to have to capture that and haul it off, right?
Correct. So we bench test the products that they were using, because at first they were like, just give us something cheaper. But we were seeing they were still barely meeting their discharge limits. So I said, do you guys mind if we look at an aluminum based? And they said, okay.
Really? I mean, you often get that, okay, go ahead and try that? Or do you get people that push back and say, well, we've never tried it that way, or we've never, how is it usually with that, of them accepting your recommendation?
It's about 50-50. Some people are at their wits' end. They've done everything.
They'll take any suggestion you have.
And they will take any suggestion that we offer them. And then others are like, I've been doing this for 30 years, and you can't tell me I don't know how to do my job. So
you want to tell him he doesn't know how to do his job, but that's okay.
Well, no, we want to tell them that technology has advanced in 30 years. Things have changed. Our understanding of wastewater has changed. And so we want to look at new technology. And so we took this company that was using ferric chloride and lime, and we introduced one of our AquaPure aluminum-based coagulant blends. Mm-hmm. And what we saw was a drastic reduction in sludge production, along with the nickel was now less than 0.9 milligrams per liter, where they were hitting right at 1.9.
Now, how soon can you tell that, though? How soon can you get a new reading on that? My team travels with hot color meters. Who doesn't? Who doesn't, right? I mean, right? You should.
So we can give you a pretty rough estimate of what we're doing on site, because hot meters have a lot of interferences that play in it. And then we can also take samples back to one of our 2 manufacturing facilities that have laboratories. In our labs, we have atomic absorption machinery where we can test wastewater samples and see where the metals are down to a part per billion range.
But you can actually, you say with that device, you can actually do it while you're there? Is that like, it's not instantaneous though, is it? I mean, does it take?
The Hawk meters usually take under 30 minutes.
Wow, that is very fast. Wow.
Yeah, they're very fast, and they're not pinpoint accurate, but they'll get you within, you're discharging within your limit and you're good to discharge. So we do have several customers that use Hawk units to test for their metals before discharge.
Let's switch over to zinc for a bit, because that's the favorite amongst a lot of people in the nickel and zinc, and zinc nickel, or whatever you want to call it. Zinc, what issues do people have with that? And kind of give me an example of where you kind of came in and were able to solve it. And how different is it to solve than, say, nickel or hexchrome? So
zinc is one of those that has 2 peaks on the hydroxide curve chart. Zinc can come out at around 8.5, or it can also come out around 10. So you really have to pay attention to your pH for zinc removal. Mm-hmm. And you want to look at your coagulant and make sure that it's a calcium-based or an aluminum-based. for optimal removal if you only have zinc in your waste stream. If you have a zinc nickel, you'll want to make sure it's aluminum anyway for the nickel aspect of it. So with zinc nickel platers, these baths are extremely chelated. And in the process of the plating application, alkaline zinc nickel can produce cyanide. So
that would be bad.
That can be really bad.
It'd be really bad.
And it also chelates the zinc and the nickel to a point that you struggle to remove it. So you'll want to segregate those rinses and pre-treat them before they go into your main system. But let's just focus on zinc. Mm-hmm. I just had a call the other day actually about a customer who was struggling with zinc removal. And surprisingly enough, the zinc was not coming from a manufacturing process. They were using a sealant that had zinc in it that they were not aware had zinc in it. And so it was a surprise for them to see they were over their limit for zinc. Right. And we discussed things like ion exchange systems and bench testing for zinc removal. So they're going to send me a sample of their wastewater, and we're going to work with it. Probably use an aluminum calcium blended coagulant because they also have some heavy oils in their waste stream. And the calcium will help remove that, while the aluminum will capture the zinc. And hopefully we'll get them straightened out soon.
It's almost like you have to be a detective. It seems like, you've got to start eliminating what could possibly be the problem. But also, like you said, if all of a sudden they started getting a higher zinc level, you have to ask them, what's changed, right? Is that the first thing, is what's changed?
Correct.
And sometimes they don't know what's on these particular things. And maybe I'm sure that was a surprise to them as well.
So we're going to switch back for a quick second because I have a story to tell you.
Go right ahead.
I don't know of anyone who hasn't had a little freelance operator in their plant.
Right. Yes, definitely.
We were working with a company who was really struggling with hexavalent chrome. Their chrome reduction system was working 100%. Their coagulants, every bit of bench testing showed that they were removing their chrome at the dosing they were at. They were dosing correct. 100% wastewater system was running the way it was supposed to run. And these hexavalent chrome spikes would come erratically and different hours of the day. A night shift would see them. It was just really odd. I was like, look, we really have to we have to become Sherlock Holmes in this instant. We got out our magnifying glass and we started tracing pipes, and we found the room that the hexavalent chrome was coming from. And it was the room where their metal removal line was at. So when they needed to do a nickel, to remove nickel from a part, to rework it, maybe the plate wasn't right or there was an imperfection in it and didn't pass quality. And so they would take it and they would do a nickel strip process. That's the room that the hexavalent chrome was coming from. So again, it still didn't make sense. I was like, there's no hexavalent chrome in this room at all. So we watched around the clock for a week straight.
Kind of like a stakeout.
Right.
Right.
And we didn't see any spikes during that week. Well, that Saturday night, their little freelance operator came in to run the nickel strip. And when you strip nickel, your parts come out very blackened and you have to clean them. This guy was bringing in hexavalent chrome from the plating line and putting it in the rinses to remove that oxide layer because he liked the way the parts looked better.
Wow, that is a complete freelance and completely dangerous. And wow.
So it was a very interesting. We definitely had to put our thinking caps on,
right?
And then we had to retrain all of their operators on why hexavalent chrome had to go through the hexavalent reduction system.
Right. Wow. That's that, like I said, that is a lot of times where they call it kind of the operator drift. Sometimes where an operator, somebody on first shift will move a knob a little bit, and somebody on the second shift move it a little bit more, and before you know it, 2 weeks, 3 weeks go by, and it's really moved. And so whether it's a coating application or the chemistry being used with that, so I could see that just popping up a lot of times with that. And again, if you don't take that step back and have a different set of eyes, like you all from Hubbard-Hall, to come in and kind of walk through everything, look upstream, downstream, everywhere. Sometimes I'm just sure it baffles them where they can't get solved with it. But let me ask you about the last metal. We're talking about copper. I have to laugh about that because most copper is in copper water pipes and stuff. So why does copper cause a problem? I mean, why is it a problem for discharging it? Is it just like any other metal, or is it?
Yes, so it is on the RCRA waste code list, and the Code of Federal Regulations also lists it as one of the 7 metals that has to be limited in discharge. In excess, it can cause fish kills and things along that nature.
So high copper levels we're talking about, very high. It has to be high, very high copper levels, or is it?
Yes, it has to be pretty high. But copper is used a lot in wire manufacturing. And then there's a lot of people that will do brass or copper parts and do a nickel plate over. So we do have a lot of manufacturers that will use copper. Copper is really easy to remove with a calcium-based coagulant unless it's chelated. So a while back, we received a call from a customer that was struggling to remove their copper. And so we went through their manufacturing process because on paper, everything they were doing should have worked to remove the copper. And we found that they were using a citric-based cleaner for their copper parts. And citric acid is considered a safer acid to use. It's got a very minimal impact on the environment. We use it to make sodas that we drink. We use it to clean our houses with. So the thing with citric acid is it loves copper and it won't release it very easily. So this was a problem that we could have tackled on the wastewater end. We could have dosed extremely heavy.
You're talking about not taking it out, just treat it, like you said, just do something on the very end instead of going upstream. And
right.
I'm assuming that's what you did, right?
So no, what we did though was we approached the customer and we said, this is what it's going to cost you to remove the copper if you stay with your current manufacturing process. Or you can look at an alternate cleaner. Let's get the citric acid out of your facility altogether and see this reduction in your chemical usage and your sludge production. And they did. They removed all their citric cleaners. They went with an MSA-based cleaner, and now they no longer have a copper issue.
There you go. Yeah. I meant to ask you, when you do a lot of I know you do a lot of these projects of, you're going into a customer. What's usually the time frame? Like you said, I know you mentioned one that, you're almost like an Amazon driver. You were there on Monday, you had it on Wednesday for them. You solved it. That, I know it doesn't always go that quick, but what does it usually take you all to kind of go in, really troubleshoot, and start putting a plan of action together? What's that usually take for you?
So if it's a customer that we currently supply wastewater chemistry for, we can be on site pretty quick and we can be troubleshooting their system within a matter of 2 or 3 days. We can also do a Zoom or a Teams meeting where they can show us the system and we can walk them through troubleshooting it remotely. So those work really well. If it's a prospective customer that maybe never bought product from us before, it takes a little bit more time because we have to look at their overall system. We have to look at all of their manufacturing processes and get a true understanding of what they're doing. And then we have to do what's called a treatability study, where we look at what's the optimal coagulant, the optimal pH range, the optimal flocculant for them to use. And sometimes they'll say, can you tell me what sludge generation is going to look like if we switch to this? So we'll do sludge generation studies. Those usually can take up to 2 or 3 weeks, depending on how in-depth the customer wants to go with that. And then we work with our sales agents that quote product and things like that. The technical department doesn't really, we try to stay out of pricing because we want to sell you a solution, not a product.
Right.
And then after that, it's up to the customer when they want to buy. Typically when they buy, we'll be on site when the product arrives to help them start it up and troubleshoot for a week. We try to stay a week with the customer and help get the system up and running properly and dial in the dosing. Because while a treatability study will show us the right products to use, it only gives us an estimate of how much to use. And typically that is a lot more than what we'll actually use when a system is up and running. So.
Yeah, well, like I said, this has been very helpful because I think, some of these examples, I can guarantee you that, people out there listening in the industry are either had this problem or having the problem, or they're going to have it. I mean, because it is a science, and like I said, these are elements that sometimes they come and they go, and like you said, parts get introduced and they bring these other elements in. So anyway, that's been very, very helpful with that. Like I said, I think by golly, we've solved a couple issues. Certainly you solved some issues with people through some of the antidotes that you had with that. But like I said, those meddling metals, those are the ones that I think just it just pops up from time to time, and it makes these operators, I think, pay more attention to their wastewater treatment then.
I think so too. I do love putting on my detective cap and helping customers solve their wastewater challenges and improve their processes. So it is my pleasure to talk to people about their issues.
Yes, exactly. Slam the case, send it to the prosecutor, you're all done. So anyway, well, thank you, Robin. This has been good. I appreciate you. Like I said, we talked about copper, chrome, nickel, and zinc, and whatever that last one you said, which was thallium?
Yes.
Did I say that right?
We did get a call from a customer who had a thallium issue.
Thallium.
And we had to use a process called advanced oxidation to remove it. So that might be a whole different.
That might be a different one. All right. Well, Robin, thank you for joining us. Seen and Solved. Again, great information and great help for all the finishers out there. They should visit Hubbard-Hall.com, read more about, because then you've got a lot of those case studies you're talking about on there. So thanks for joining us.
Thank you, Tim. As always, it's a pleasure speaking with you.
Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to Hubbard-Hall.com or wherever you get your podcasts.